continuing our discussion on blood. Again, we know our red blood cells make up in the high 90% all of our blood cells. So, and we know that they are made in our bone marrow, and that when the cell's being made, it does start out with a nucleus, but when it enters the bloodstream, then it has lost its nucleus. And so we want to look at, the next thing we'll look at is how are all of our white blood cells, or excuse me, all of our blood cells, including our white blood cells, how are they all made? And so look at this picture, or this PowerPoint presentation slide, and notice that here's our red blood cell. So here's our erythrocyte. And then notice here's our other blood cells. So here's our white blood cells and our platelets. Here's our other formed elements. And these being our white blood cells, these being our platelets. So we know that the high 90s, 98% plus of our stem cells are going to go this direction to form this. But what is it that determines whether this stem cell back in the bone marrow called a hemocytoblast, what determines whether why most of it's going to actually become red blood cells? Because this very same stem cell could have gone any of these paths to become any of these cells. Now again, we're going to be talking more specifically about, what's the difference in a basophil and an eosinophil, neutrophil, monocyte, and a lymphocyte. We're going to be talking about the differences. But right now, we're just trying to say what determines what type of cell our stem cell eventually becomes, as far as which blood cell will it become. Now again, obviously, if we start here at the stem cell area, and notice even our next level is either going to be what's called a myeloid stem cell or a lymphoid stem cell, what determines whether the hemocytoblast becomes even a myeloid stem cell or a lymphoid stem cell? And the easy answer to this is it's according to what chemicals, what factors the hemocytoblasts are exposed to. Now notice in our picture, if a hemocytoblast is exposed to something called multi-colony stimulating factor, CSF, then it will become a myeloid stem cell. If it is not exposed to multi-colony stimulating factor, then it will become a lymphoid stem cell. And then if it becomes a lymphoid stem cell, it will eventually be developed into a lymphocyte. Now, lymphocytes, there's actually several kinds of lymphocytes we'll be looking at later on. They are primarily what we would call the B cells, T cells, and even something called a natural killer cell. All those are lymphocytes, but we'll get into that a little bit later. But again, they are derived from a lymphoid stem cell lineage, and that was derived from a hemocytoblast that did not get exposed to multi-colony stimulating factor. Okay, so that's pretty much a direct route. Now, it doesn't mean they're not exposed to other things, but as far as the factors we're going to talk about here, it's not exposed to the factors. Okay, so if a hemocytoblast is exposed to multi-colony stimulating factor, then what determines whether it goes this route, or this route? Well, if it's then exposed to EPO with this erythropoietin, which is a hormone produced from your kidneys, then it will go this route. And later on, it'll go through the different stages, get exposed to more erythropoietin, and then erythropoietin, what that basically does is it tells the cell to start building a bunch of hemoglobin. And then, as we mentioned before, the hemoglobin becomes 95% of the cell proteins, which causes the actual, nucleus to be expelled along with most organelles, and then we end up eventually with our red blood cells. So we again know this is the actual pathway that most blood cells will become, going from the stem cell to the numerous amounts of erythrocytes that we have. Okay, so what if we are exposed to multi-colony stimulating factors? So we're going to go on the myeloid stem cells, and we're also exposed to GM, colony stimulating factor. Now, G stands for granulocyte, M stands for monocyte, colony stimulating factor. Then we will go this route, and we won't go this route because we were exposed to this, not to erythropoietin. Now notice this route was exposed to multi-colony stimulating factor, but it was not exposed to erythropoietin or granulocyte monocyte colony stimulating factor. Okay, we'll come back to this path in a minute. All right, so let's say hemocytoblast is exposed to multi-colony stimulating factor, so now it's a myeloid stem cell. Then it's further exposed to granulocyte monocyte, which is GM, colony stimulating factor. Now, it will then be determined that it will either get exposed to the granulocyte colony stimulating factor or the monocyte colony stimulating factor. If it is exposed to the monocyte colony stimulating factor, then it will eventually become a monocyte. If it is exposed to the granulocyte colony stimulating factor and becomes a myeloblast, then it will actually have three possibilities of what it will be able to turn into, either a neutrophil, eosinophil, or basophil. Okay, so again, if we followed a neutrophil, said, well, what was a neutrophil exposed to become a neutrophil back here at the stem cell level? Then we would say, okay, it's exposed to multi-colony stimulating factor, it's exposed to GM colony stimulating factor, then it is eventually exposed to granulocyte colony stimulating factor, and then in this case it became a neutrophil. Okay, now so again, the myeloblasts were cells that were exposed to the GM colony stimulating factor and the G colony stimulating factor, and they can be one of these three. The monocyte was exposed to the monocyte colony stimulating factor and the GM colony stimulating factor and the multi-colony stimulating factor to become a monocyte. All right, so what if a hemocytoblast is exposed to multi-colony stimulating factor but not GM or not erythropoietin? Then what it will do is it will develop into something called a megakaryocyte. And the important thing about the megakaryocyte is it fragments, and its cytoplasmic parts actually become the platelets. So if we said, where do platelets come from? And of course, they're part of what we use to help clot our blood. We say, well, platelets are fragments of a megakaryocyte. A megakaryocyte was from the myeloid stem cell. It was from also, as all these cells were, it started out as a stem cell called a hemocytoblast that got exposed to only multi-colony stimulating factor. So I would expect you to be able to look at this chart and answer questions about, what were the different blood cells exposed to, what factor or hormone were they exposed to become what they became. And again, you don't have to memorize it, but you do need to know how to interpret this picture and answer questions about it. Now going back to our formed elements, knowing that some of those stem cells, the majority of them, in this case 99.9%, which I think that's a little high, but it's still going to be very high, but you will see different numbers from different books, will have been exposed to erythropoietin and becoming red blood cells. But what are the other white blood cells? Now again, the platelets came from a megakaryocyte, they're fragmented, and the megakaryocyte only got exposed to the one factor, the colony stimulating factor, and then it fragmented. But these cells, the white blood cells, the leukocytes, are in these large categories here. Okay, now we actually break down the white blood cells into two categories, and we can kind of see the two categories even looking at these pictures. We have what's called the granulocytes, and here we can see this, if we stain these, as we see in the picture, that the cytoplasmic elements hold the stain, the granules hold the stain, and the cytoplasm, we can see the stained cytoplasmic elements in it. So a basophil is a granulocyte, a neutrophil is a granulocyte, and an eosinophil is a granulocyte, or they are agranulocytes. Here we see that the lymphocytes are agranular. In other words, if there's the nucleus, but if I look out here, I don't really see, stained. Doesn't mean it doesn't have cytoplasmic elements, but they don't hold the gram stain. And same thing here. Notice I see the nucleus here, but the actual cytoplasmic area doesn't have these dark stained areas of their cytoplasm. Now, again, we can kind of relate that back to what we were just talking about, we can look and see that the granulocytes here, again we can see the granules that are hold on to the stain, or the neutrophils, the eosinophils, and the basophils. And the agranulocytes, remember the lymphocytes weren't really exposed to any of these factors, and the monocyte was exposed to monocyte colony stimulating factor, but not granulocyte colony stimulating factor. So according to what they were exposed to, and then if you take microbiology, you will identify them by using the gram stains and seeing, well, which ones held on in their cytoplasmic elements to that gram stain. So it's kind of, a way to identify and to use their development to help us identify their categories. Now look, here's our relative percentages. So our most numerous white blood cell are going to be our neutrophils. They are 50 to 70% of our white blood cells. They are phagocytic cells. In other words, they do engulf things, but we'll talk more detail about what they do, but these definitely make up the biggest percentage of our white blood cells, followed by our lymphocytes, which are our B cells, T cells, and even natural killer cells, primarily B and T cells though. And they make up what we call our specific defenses, which we're going to be talking about in great detail when we get to immunity. All right, so next then, my monocytes, I like to call this Clark Kent, because we know Clark Kent turned into Superman, and monocytes have the ability to turn into a cell called a macrophage, which is a really incredible killing cell. It kills a lot of infections and stuff. All right, so anyway, monocytes make up 2 to 8%. Then finally, eosinophils, which are kind of specialists. We primarily see them in certain conditions we'll talk about in a minute. They make up 2 to 4% of our white blood cells. And then finally, our very specialized basophils, they make up less than 1% of our white blood cells. So here's our relative numbers. So let's look at these and talk about very quickly, introduce, because this is where information starts transitioning from test 1 to test 2. Okay, neutrophil, again, makes up 50 to 70% of our white blood cells. Again, it's a granulocyte. You can see the granules that are stained outside of the nucleus here. These highest percentage, so they're usually the first thing to come across an infection or an invader because they are the highest percentage. But these usually, when they actually attack invaders, they usually die in the process. And if you've ever had an infection that created pus, pus was actually dead neutrophils and whatever they had engulfed or killed, whatever bacteria or virus or invader that they had attacked or killed. So neutrophils, very important. Okay. Monocytes tend to follow neutrophils around. We'll talk more about that a little bit later. All right, we'll come back to that. Now, lymphocytes are agranular. You can see this huge nucleus, but the cytoplasmic element is not stained like you see the stains here in the eosinophil or the neutrophil or even the monocyte. Or excuse me, not the monocyte, but the basophil. All right, but these make up our very specialized, we call them specific defenses. We'll talk about what that means later on. Again, these make up our B and T cells, but these make up 20 to 30% of our white blood cells. Okay, our next highest percentage is our monocytes. Monocytes, again, they follow neutrophils in the blood, but they actually turn into a cell called a macrophage to actually engulf and do a lot of damage. They also make up something called antigen presenting cells, and we'll talk about what that means later on. Very important concept. Monocytes are just incredible killing machines, but we don't have near as many of them as we do neutrophils. They don't tend to die in the battle like the neutrophils do, but they actually help activate our B and T cells, and we'll talk about what that means later. Okay, eosinophils. We tend to see eosinophils in 2 different conditions. Now again, we can see the granules here, so they are granulocytes. And again, the top row here is the granulocytes. The bottom row are the agranulocytes, meaning that their cytoplasms don't hold the stains like the granulocytes do, and their formation was different. All right, but eosinophils we see in allergic reactions and also in parasitic attacks. Basophils are actually release chemicals called inflammatory mediators, histamines being the best known one.